And he's going to be leading a panel on machine learning's impact on business models and industry structures. Please welcome George and our next panel.
Okay, good to be here. And this is a live test of the production quality of iPad 3, which I haven't been able to take my hands off of since I got it Friday. But we're here to talk about machine learning. It's a bit of a black box to many of us. And so I wanted to set some context as to what I was hoping we can accomplish in the 35 minutes we have. And then give it, let the speakers introduce themselves and talk about sort of what they're building, what their mission is as it relates to machine learning. So this is an ambitious sort of stretch, but the topics I'd like to go over are how can the vendors that our panelists represent use machine learning to differentiate their own offerings, and then how do their customers differentiate their offerings after applying machine learning? And can they actually gain a lasting competitive advantage if, as vendors, they're supplying their customers' competitors? And then the third is, how can our panelist companies be better at building data-driven enterprises internally? The last one, which I hope we'll have time at least to comment on, is a generic business model around machine learning businesses. 30 years ago, Microsoft made it clear you could build a major software company independent of hardware. And the question that I hope we can touch on is data as the intel inside enough to build major companies around machine learning, or do you have to integrate all the way back to the raw data, or at least some of the raw data sources? So having set that context, let me ask each panelist, starting with Currie from IBM, to do a quick intro, what their product does, and how machine learning fits into that mission.
Good, thank you. So I work in natural language processing. I like to say we're in the intent business. We try to understand whether it's somebody's looking for guided selling assistance or guided support, or looking for information, or looking for processes and documentation. What was their intent, and then do interactive query refinement. In the perfect world, users would ask you a well-structured question which was both complete and specific, but very rarely does that happen. So if somebody is looking for information, what is the intent of what they're actually seeking, and how can you interactively, without rules and scripts, drive out a complete and specific definition of that in order to be able to go and retrieve that information. So the intent business.
So I started working in trying to do big data machine learning 18 years ago at NASA. We had to worry about this and didn't know anybody else who was talking about big data or even machine learning back then. I went on to become a professor at Georgia Tech and have a lab that does research on this, probably the biggest academic lab, trying to figure out how to scale up machine learning to big data. And our company, Skytree, is nothing really has changed in my view in the 18 years that have passed as far as can you buy machine learning that works on big data. So we're trying to fill that void with the first truly scalable enterprise-grade professional quality machine learning system. It's called Skytree Server. And basically bringing the best that's known in high-performance computing research, machine learning research, and applied math research.
Mo?
Hi, I'm Moke O. I'm Chief Scientist at PayPal. Who among you have not heard of PayPal before? Show hands. Okay, so that's what we do. Actually, I brought a toy, actually, so I just wanted to show you guys our new encrypted card reader called PayPal Here, and basically pop it in, and you can swipe. It's cool stuff.
Any just want to add like the role of machine learning in
It works with Siri. But, it's all about collecting data, basically. So what I usually say is garbage in, garbage out. The opposite works really well, too. If you have great data, then lots of possibilities can happen. Now, as we're looking for great data out there, I think this is going to be one of the major ways of getting good stuff. And I usually say, what search is to Google, transactions are to PayPal. Transactional data is a strong, strong signal that tells you your buying habits. So it's a great way to try to understand people's intent on buying stuff. So once we have the great data, then the science part, I think, will flow naturally out of that.
Okay. Amarnath?
So I'm Amarnath. I run strategy and analytics for Match.com. I hope I don't have to explain what Match.com does. So we use machine learning to get smarter at everything, including marketing, product development. But probably the most fascinating part where we use machine learning extensively is to decide who to match up with who. So all our matching algorithms are driven by machine learning.
So just in the interest of full disclosure, and I've told Amarnath before, I'm actually a member, so I was trying to get all the secret sauce out of him. He was being sufficiently discreet.
I think I've already answered the question how my customers are gaining advantages of machine learning. So George probably is.
All right, so going back to the sections we want to talk about, how would a panelist vendor use machine learning to differentiate their offerings? So, Currie, let's start with you.
Sure. So with the natural language processing, we do it to transform the way we can interact with our customers. Either selling directly via human or through business partners is one way to be very specific about what the person's actually after and be able to find good information for them. But selling over the web is pretty hard to do if you have 10,000 products and you work in hundreds of countries. So we're using the idea of natural language processing to help us with the concepts of helping do guided selling as well as guided support in terms of what we do with our we're working on towards our call centers and what we do on IBM.com now to help people be more successful. So the thing is, and this is true for all of us, is you never stop learning your machine learning. People agree that the techniques are well established, but the way that people interact with you, the way that you want to interact with them, kind of without the human, but to emulate the human, is where we use machine learning as a process to say, well, we did this and we had these outcomes. These percentage were successful, and probably more interestingly than the percent that are successful is trying to understand the percent that were unsuccessful and why they were unsuccessful, and did they decide to buy from your competitor, or did they decide that they had to phone you for call center support. So we use machine learning for that.
So let me home in just one level deeper. Do you see that these solutions, as they apply to financial services companies, telcos, these multi-channel outlets, are they going to be ultimately packaged apps the way we know of SAP and Oracle business apps, or are they going to be bespoke, custom solutions that are specific to each organization that you sell to?
Good question. The next phase is with our customers, and certainly. So the engines that do the machine learning and do the natural language processing will be assets or products. But the implementation, so you understand the language domain that's specific to them, their product sets, how their customers interact, is the services that we put on top of it. But that's where we see the differentiation of being able to transform our clients from being relatively static in terms of the way they interact with their customers to being human-like in natural language processing, and human-like in terms of machine learning. The more that you use it, the more successful it is for you and for others.
Okay. Mocha, I want to come back to you. We saw the PayPal reader, but I want to ask...
PayPal here.
PayPal what?
Here.
Here, sorry. Want to ask more about the broader mission that you told me about of connecting customers and merchants,
Yep.
and that's a conversational engagement that takes place over time, and it's pre-sales and post-sales.
Yes.
So how can machine learning make that more effective?
Right. So you can think about it one way is what we're trying to do is make people shop more conveniently. Ultimately, what you want to do is connect up buyers with sellers and vice versa. A lot of times people call it merchants and consumers as well. It turns out there's there are a lot of merchants out there as well as a lot of consumers out there. I mean, tons more order managers, more consumers. Ultimately, if there's a human in the loop in between trying to match these people up, it's not going to be efficient. So how do we do that efficiently? It becomes the question in a cost-effective way. We can, hire lots of salespeople, lots of feet in the street, and just go out there. And a lot of times, business models don't work that way just because it's way too expensive. So the question then becomes, how do we effectively connect merchants and consumers and merchants at a scalable way and scalable and cost-effective way? That's what you're looking for. And machine learning comes over there. And so in that framework, there's lots of different use cases, from online connecting to offline connecting. At the point of sales, what are complementary merchants that are all around that will do this? To NLP, when there are lots of unstructured data everywhere. How do you make sense out of that? How do machines make sense out of that? So there are lots of tactical things you can do trying to connect these people together. But ultimately, that's what it boils down to, is buyers and sellers. How do you connect them?
So just to follow up on that, you and I had talked about a couple scenarios where we don't know ultimately sort of which path it'll follow, but we talked about like a Mint 2.0 where it's customers' personal information, preferences, location, payment history, and then the merchants plug into that based on your ownership of your personal information.
Yep.
Or a Yelp 2.0, which is more of a merchant directory.
Yep.
Or more of a primitive sort of ad exchange.
That's right.
In an informational, portal.
Yeah.
What role would you be playing in those?
Well, you want to do both, actually. So there's a couple value propositions for PayPal, which are somewhat different. When we say customers, it's both merchants and consumers. And you have to think about what's the value prop for the merchant. It actually turns out it's very different from what consumers want. So we have to think about both, what's going to be what. And ultimately, of course, the merchants want to know about their customers, and of course, the consumers also want to know more about the merchants, right? So that's data.
So, but beyond the data, then, and I don't want to sort of go too far down the rat hole, but it sounds like based on that data, the merchant can build a better model about the consumers using machine learning and what they're likely to respond to. And the customers can build a better model of what they're interested in.
Yeah. That's right.
Fair?
Yes,
okay.
That's right.
All right, so this one's the most fun one, Amarnath, because, hopefully I'll get some more secret sauce out of it. So what exactly happened when Match.com realized they had more data on how pairs match up? Not like that bogus Wall Street Journal article this weekend about, the idea of matching like pairs, doesn't work. What did you learn about what people said they wanted versus what they really did want?
Right. So, I think my view, when we decided to approach the whole matching problem, we read all the books on psychology, we looked at all the theories, but they're just theories. And then what we said is, look, there doesn't seem to be a formula out there, and we probably all hope there isn't any formula out there, right? So we decided to come at it differently, and we said we have 15 years of data on what actually worked for people. And we have billions of people who've used the site, who are using the site now, who's used the site in the past. So what can we learn by mining that data of what actually works? And these are decisions people have made by themselves. So what we decided was we mined all that data, and then without taking any point of view, essentially generated an equation that says this is what happens. These are the kind of people that like these kind of people, so hence that's what we should recommend. And then the other fascinating thing that we learned was that was not enough. So building models just based on what people said they wanted was not giving us great predictive results. And then as we mined deeper into the problem, what we realized is what people actually do on the site is very different from what they say when they create their profiles. And that was a pretty much very fascinating wake-up call for me, which is and when we started focusing our algorithms more on what people actually did on the site, we saw almost like a 2x increase or 3x increase in predictiveness of our algorithms. So while you can start with what people say they want in any business, and that's just a starting point for where you can start building machine learning equations. And when you layer in what people actually do, that's when I think the real meat shows up.
So just, I want to come back to you next, Currie, but just can you give us an example of what someone says they want versus what they really do?
Yeah, sure. So, I mean, there are a lot of, we see almost all parameters being broken, and it's surprising. Like, one of the most commonly broken parameters is income, which would be very surprising. And one of, so when people have this idealistic notion of like, I want a person who makes more than X dollars a year, but when they actually see everything else that the person represents, they say like, nah, that's not that important. I'm going to just ignore that. And it's not surprising if you relate it to real life, you see that all the time. Whereas the other interesting end is smoking. If that's one of the least broken criteria on the site. So I mean, it would be surprising if you said society as a whole will never compromise on whether they want a smoker or a non-smoker, but income, yeah, that I can deal with.
All right. So, Currie, you had said something interesting when we were talking background about how, in terms of helping customers differentiate their businesses, a lot of businesses take financial services, basically offer the same products. And they're, it's very hard for them to differentiate. How could an IBM come in and change that?
Good, thanks. I'll just note one interesting thing on machine learning, and that's that you mentioned that the models change every quarter. Like the societal behaviors, we know how much data is coming in and it changes, but things change every quarter, and they have to relearn their models and teach their models and do machine learning based on that, which is fabulous, I think. So Watson's really changed the way that people look at unstructured data. It's been, I think, good for our industry that people now think differently about it. And so with Watson and Watson-like technologies, there's really two sides to how businesses now look at this, and certainly consumers or business to business. And that is on the sales side and the cost side. So on the sales side, people are really looking at different ways of finding potential consumers, winning them over to their brand, making decisions. So for instance, they bought a car recently, and it was good that they followed up with the engineering reasons about whether I was having any problems, but they completely missed the why did I choose their product over somebody else's product, into the way that they looked at me as an information source. And really, I think this is where we need to get to, is where does brand preference come from? What drives it? What drives the consumer behaviors? What deals did you win? What deals did you fail to win? And why did you fail to win those? So really, that's, I think, been the thing that everybody's looking for transformational. I won't say that many industries are now undifferentiated in commodities, but if you try and think about the ones you regularly work with, their product sets are very similar from product to product. And so some of the ways that people have been keeping customers has been just how hard it is to change, the barrier for departure. But now the barriers for departure are breaking down. It becomes more and more important that actually organizations are very effective at knowing what you need and retaining you on a daily basis rather than just transfer you to the retention department when you're on the way out the door. So I think that's where the differentiation is really going to come.
So, back to the old sort of magical mix of people, process, and technology. When companies first started putting in big ERP systems in the early to mid 90s, they didn't really get the benefits out of them until they reorged around shared services. Mm-hmm. Is there a similar phenomenon that's got to happen for companies who are putting in these sorts of systems where you can't really get the best benefit out of it until you have a different sort of process to leverage them?
Well, in theory, we hide all that. In theory, that all information is available across lines of business, and it really was that it wasn't available in a consumable way. So right now, the idea with machine learning and natural language processing is that you have data sets, you don't even know if they're valuable or not, but the cost of computing drops so much that you can now go and research them and find out if they're valuable. So I think the theory is that you isolate the process and the data from the organizational boundaries or even the intent of why that data was originally collected. And we can not force people into having to learn new methods and approaches, and our job is to hide all that from them and yet derive data for it.
So it would be fair to say that you could have the multi-channel mobile experience where you can interact via SMS, email, web, native, kiosk in the store attendant with a tablet, that sort of thing. And
email, write-in comments, website comments, and it would all be aggregated, and they would know you as an individual regardless of the channel, right?
Okay. Alex, I want to come back to you on the business model question, but before that, in building a data-driven enterprise, Amarnath, you and I had talked about making sort of testing, A/B testing of everything.
Yes.
The DNA of the organization.
Right.
Can you elaborate on what that means for user engagement and the effectiveness of your marketing campaigns?
Sure. Yeah. So I think traditionally we say that businesses that listen to their customers succeed. And I would just like to change that a little bit and say businesses that observe their customers will succeed in the future. And I think machine learning essentially is a great way to observe what your users want, what they are actually doing. I mean, instead of depending on focus groups or surveys that you could do like once a year, or once in 6 months, if you observe on a daily basis what customers actually are doing and wanting, that's a great way to improve your business and gain competitive advantage. And that's where A/B testing comes in. So essentially you need to, once you understand that principle in its whole, then you can change your entire organization to define every product feature or every marketing decision that you make based on rigorous A/B testing and machine learning, which is interpreting what those A/B tests are telling you and iterating on your product and on your marketing campaigns through those results. And specifically, I mean, we've seen fascinating results in both the effectiveness of our marketing campaigns, because we look at every marketing campaign as a combination of various factors such as creative, placement, audience, and then almost on a daily basis, or sometimes even on an hourly basis, we are changing what marketing campaigns we have out there based on the response we get from customers. So also, for all product features, it's never like the loudest voice that wins or the strongest opinion that gets through. Everything is like, sure, let's test it. And then you have to get statistical wins in an A/B test for anything that to get on the site. And once that culture sets in, I think you respond to your customers much faster than anyone else can, and that inherently brings you huge competitive advantage and customer retention.
Okay, Alex, in my notes I seem to have sort of grayed out a section that I can't read. But you and I had talked about being a more effective data-driven organization as well. And since it slipped my mind, I need you to remind me what we talked about.
Well, so, I think our prediction is that the trend is, one day every organization will need to do machine learning. So it's sort of leading companies that are pushing the edge and showing the way, Netflix Prize, Google AdWords, and so on. And of course, the co-panelists here. But eventually, it's going to be sort of a matter of survival because your competitors will be running all the parts of their business that they can run with data rather than human decisions, or augmenting human decisions with data-driven processes. So it's going to, there was a book called Competing on Analytics. So it will become very real and very fierce at some point. And so, what we're offering is better machine learning. How do you make it better? Well, it's a key problem right now is you can't do advanced methods scalably. The advanced methods are the ones that give you the higher accuracy in prediction or better understanding of your variables and so on. So there's no free lunch. You want better statistical performance that implies much higher computation.
Can you explain the relationship, where your data set might grow this amount, but the computational horsepower grows,
Exactly.
geometrically?
So simple machine learning methods, which is where many organizations are today, the ones that are using machine learning, are scale linearly, typically with the number of records. So whereas sort of the latter half of the machine learning textbook, if you will, the advanced methods, well, those tend to grow quadratically or cubically with the number of records. So, the upshot is you want higher accuracies. For whatever reason, find more fraudulent transactions, predict whether tomorrow's stock price will be up or down better than your competitors, and predict demand of sales better than your competitors, so on. Well, you want to go to more advanced methods. Now, you also want more data. For any method that you use, the more data that you feed through it, the better your predictions will be. It's a fundamental theorem of all of statistics. So it really comes down to a big computational problem. And other things, too, that you want confidences on your predictions. Well, to do that, the best way to do that is to run it 10,000 times with randomization and so on. So everything that you want to do that gets more sophisticated implies massive amounts of computation.
You had told me that, I think it was AdWords from Google, is still on the sort of middle of the spectrum in terms of sophistication, taking into account like what the advertiser might bid and what's the likelihood of a click. And for all of us neophytes, we would have thought Google, they already landed on Mars. That's pretty sophisticated. How much better can that get, or what qualitatively would we see that's different if you were using the really sophisticated stuff?
So right now, even these leading examples, typically, we're just starting essentially from my viewpoint in industry to just start using machine learning. So the linear model is, or other simple models are better than no machine learning, much better, and we're seeing that. But the next level is of sophistication will be higher accuracies, higher click-through rates would be implied there. Also deeper understanding. You could understand which variables are actually driving the predictions in a deeper way. Like I said, you can get confidences. So basically better.
Okay. That boils it down. Let me come back at the risk of sort of honing in on you and putting you on the hot seat, the notion of the sort of the generic business model by which we might commercialize machine learning, across problem sets, across industries. You had mentioned to me a weather forecasting company, which use for where their customers are essentially offshore drilling companies. And I looked that up, and I was like, well, what's the difference between that and weather.com and or the Weather Channel? And they actually take, I guess, very detailed local weather forecasts and apply it to things that would be relevant to an offshore driller, like, the peak waves, peak wind, things like that. How would the amount of data affect that, and how would that work if you're delivering that service from the cloud? How do you get all that data in the cloud, and then how do you get it out to the customers?
So as machine learning becomes more prevalent and necessary in all industries, I think we're going to see a lot of business models emerge around people providing machine learning. So right now what we see is that companies are trying to build their own in-house because are doing it one way or the other, often cobbling together open source stuff or writing their own stuff. Of course, this is very time consuming. It requires a lot of expertise and a lot of duplication of things that are known and so on. And it, in my opinion, they rarely get to the best stuff because they've got their own problems to work on, business problems. So going to emerge people like us. We're the first people to say, here's a platform. It does machine learning. It's enterprise software, just like a database. It plugs seamlessly into your IT ecosystem, connects to your database or other data source, also connects to your front end that you're using, R, MATLAB, Python, whatever. But there are going to be other people who will just do predictions for you as a service. You maybe send them data, and it'll be hidden behind a curtain how they do the predictions. There will, of course, emerge many industry-specific versions of both of these. Now, we just do predictions for you kind of implies a cloud model. Whether the cloud works or not in a particular instance, I think kind of depends on, well, for one thing, batch machine learning is probably not going to work well on a cloud because if it's big data, because you have to send the data to the cloud, and the sending of the data can swamp even the compute time. It can take a day or whatever, depending on the size of the data. So unless the data is on the cloud, it starts on the cloud, that's not a viable option. So one thing that can change all of that is a streaming model, and that's actually what we offer. So if your models can be dynamically updated, then as you send data, you don't have to wait for the whole blob of data to get to the cloud. As the data are being sent, the model is being updated, predictions are being sent back. So that's something that we offer, and I think that can make the cloud model viable.
All right, so we went a little longer than I had hoped, but let me just sort of recap that, on the panel we have represented IBM, PayPal, and Match.com, who've taken machine learning and made it part of a solution or service that they're offering. And then with Skytree, it's more horizontal, sort of back to the old data management and tools or application development environment that might sort of sit in between or on the pipeline between the information capture and transactional systems and, the more traditional analytic systems. And I'm hoping what everyone took away is that, we're going to see multiple paths towards commercialization and that there are really widespread applications for this. So with that, I think it's we have to let our next panel come in And I just want to thank our panelists for a very interesting discussion.